Well, welcome everybody. I'm still expecting that we'll have a few more people join, but it's great to have those of you that are here so far. So we have the fantastic team at Graphy, who are going to be running a session called The Magical World of Modern Data Viz, which I'm quite excited to hear about. For any of you who haven't come across Code and Black Females before, if this is your first event, Code and Black Females are an organisation set up to enable more Black women to enter the tech industry, but also progress through the industry as well. And we have a huge range of events that we do independently, but also alongside our partners to enable our members to find out more about technology, but also the industry and how fantastic tech is. I've been in the industry for around 12 years now. The number keeps increasing and it upsets me, but it's fine. I've been in the industry for quite a while, and it's actually been quite exciting to see the change that is happening in the industry because of organisations like Code and Black Females and also the sponsors that are keen to make sure that we can see a change. So I am going to hand over to Liz, who is going to run a session now, and we will be open for questions at the end. So if you have any questions throughout, please feel free to drop them in the chat. And if anybody would like any transcription, there is also a live transcript button in Zoom, which will enable you to have transcription as well. So I'll hand over to you, Liz. Thank you.
Thank you very much. Right, hi everyone. Welcome to this Lunch and Learn. I'm going to share my screen now, so hopefully that will go to plan. And I'm going to try and speak clearly so that the transcription thing works, because we all know that the automatic transcription stuff sometimes isn't the best. Okay, all right, hide floating meeting controls, #1 thing to do when I start screen sharing. Right, let's go. Okay, so this talk is about the magic of modern data viz. And so the intent of this is just to be a really high level look at the field of data visualization. And I'm hoping to address a few questions like, what is data viz? Why is visualizing your data important? And how can we get started with building data viz of our own? So data viz is something that I'm personally really passionate about. And I would be really, really happy if at the end of this talk, you're as hyped about data viz as I am. So just to be a little bit self-indulgent, I'll just give a quick intro to myself. My name is Liz Curtis. I'm a senior full stack engineer at Graphy, and the team I work on at Graphy focuses mainly on our data pipeline and data visualizations. Data viz has a very special place in my heart because it's actually how I landed in my first engineering role. I always was interested in programming as a hobby, but the other great love of my life is history. And at the time, I was actually participating in a volunteer program transcribing census data for a genealogy company. So I don't know if you've ever come across census data before, but here is an example of the 1911 census. And I am a bit of a nerd, I have to admit, but I think censuses have so much cool data to crunch. So for example, here you have people's names, you've got their relationship to the head of family, ages, marriage status, profession, birthplace, all that good stuff. So essentially I was in data heaven, this was me. And I reached out to the organizer of the transcription volunteering thing and said, can I have some permission to visualize this data? Because I think I could make some cool charts with this. And the response I got to that was I was asked if it would be possible to create an interactive map of Dundee where you could see who lived on what street in which year. And now I had never done map visualizations before. I'd only kind of tinkered around making bar charts and things like that with Python and Matplotlib. But I was like, okay, why not? Let's give it a go. So I built a map visualization using React and Leaflet.js, which is a JavaScript library for maps. I got some positive recognition out of that and landed my first engineering role. So it's safe to say data viz has a very, very special place in my heart because it was the start of my journey, and it kind of continues to be my journey, and I love every day of it. Enough about me, let's talk about actual data viz. So modern data viz, what is data viz? How is it different now to how it was in the past? So historically, when you think about visualizations, you might think about printed charts and things like that. So for example, the kind of charts that you might see in the newspaper, that kind of thing, you're kind of just like passively absorbing that information. But what I think is really great about the modern web is that we have these libraries like D3JS, which enable us to build interactive experiences. Now, why is interactivity great? And I think that's because it's really engaging for the viewer. It encourages you to explore the data for yourself, which fosters a stronger understanding of that data. And it also increases transparency because it's a lot harder to build something misleading when you're actually allowing your viewers to kind of click around and explore the data for themselves. And I think data viz is kind of undergoing a sort of like renaissance right now. A lot of people are enjoying beautiful data visualizations and kind of like leaning towards interpreting data viz as art. So as an example of that, you might know the website Reddit. There is a subreddit on there, which is kind of like a special interest community called Data is Beautiful. And it's one of the fastest growing subreddits. So this is something that people truly are interested in and excited by. In my experience. So let's look at a couple of examples of some charts. This is one that you might be or probably are very familiar with, bar charts. One very important thing when building data viz is that you choose the right chart type for the type of data that you have. So bar charts are very good when you have this kind of discrete data. So here we have a chart which is just plotting some sample data, amounts of fruits. And what do we mean by discrete data here? If we look at these labels on the x-axis, these are all completely, they're separate fruits. They don't have any relation to each other. There's no continuity. It's not linear. So a bar chart is great for this kind of data. And on the other hand, when you do have continuous data, you would probably want to plot that using a line chart. So here is an example of a line chart. So here we have stock values, stock prices over time. And this is exceptionally good for these kind of like time series types of data where you want to see how something improves or goes down over time. So these are probably the two most common chart types. You've probably encountered them in school. They're quite familiar. You might think that they're a little bit boring. You might think, do I want to go into data viz? Do I want to spend my life just making line charts and bar charts? Is there no room for creative exploration? And actually, the answer is there is room for creative exploration. So if you really like to push boundaries and you're a creative sort of person, there are more ways to represent data. You can sort of infinitely push those boundaries and think outside the box. And I would like to share a couple of examples there. So this first one is Film Flowers by Shirley Wu, who is an awesome data visualization expert. So this is top summer blockbusters reimagined as flowers. So here is the legend for this type of visualization. And you can see each of these elements of the flower represents a different thing. So we've got the shape of the petal representing the age rating of the film. We've got the color representing the genre. We've got the number of petals representing the number of IMDb votes. And we've got the size of the flower representing the rating. And as we scroll through this, you can see there's like a lot of variation in these flowers. It's quite beautiful. There might be an argument here that maybe this is form over function. And if you wanted to actually like look and interpret this data, there might be a better way of visualizing it. But this is certainly a novel way of visualizing it, right? And so I just wanted to share this as an example of the kind of things that you can do. You don't have to stick to boring charts. You can make beautiful data art. And this is the kind of thing which is also like won some awards. And this sort of thing is also quite popular to actually like sell prints of, just because it's got that pure like aesthetic appeal. That's another example of something which is like a little bit more interactive and interesting, and again kind of pushes the boundaries a bit of what data viz is. There's this visualization by Nadi Bremer, which is why do cats and dogs, but I'm focusing on why do dogs. And this was a project sponsored by Google, and it was designed to visualize the most common search phrases that a user looks for, starting with why does my dog or why do dogs. So we can look at this kind of chart here, And this is quite fun to explore. You can see we've got the most common word lick here. Why do dogs lick? That's the most popular search phrase in this like large bubble in the center. And as we go out towards the outside of the circle, we can see why do dogs lick people? So it's kind of like building up that sentence phrase. And we've got some like really obscure search terms on the edge. Why do dogs lick their mouth? Less commonly searched for. Why does my dog rub her eyes, then lick her paws? And you can see this is a really, really nice way of visualizing data. It's quite interactive, it's quite novel for the user. Again, it's designed to be explored. And I won't go through the entire page. At the end of the presentation, I'm going to be sending through an email with links to these resources, so you can kind of look through them at your own time if you'd like to explore. But I just wanted to highlight this as an example of the types of things that you can build when you're building data viz for the modern web. So let's head back to the presentation slides. So for me, data viz is this perfect blend of engineering and design, and it's all about keeping that equilibrium of form versus function. You want to design something beautiful, you want to design something that's engaging, but it also needs to be accurate, and it also needs to be accessible, and it also needs to be performant, especially if you're building for the web. So the question that I'm mostly asking myself when I'm building a data visualization is, what is the best way to represent this data in a way that's accurate, easy to interpret, and doesn't look like it was built in the 90s? So here's an example, and apologies to whoever created this chart, of a chart that I think is not very nicely designed. So this chart is from storytellingwithdata.com, and to be fair, this is from a blog article from 2012, so it's quite old, and we can't blame them too much for how it looks. But it's not very appealing to look at. This is the sort of thing that I would think that most people think of when they think of data viz. They think of these kind of boring reports that you'd get printed out with these ugly charts that were made in Word or Excel. And if we compare this again with the chart that we saw earlier, we can see that this is a lot more visually appealing. So you have some kind of design principles coming into play here. We can see this one is nicer because you've got a higher contrast between the sort of this blue color against the white background, as opposed to that dark blue on the dark gray background. We've got the tick labels are just horizontal tick labels. We haven't rotated them. We were using an attractive font and so on and so forth. So you can see there's this sort of creative design element that comes into building an appealing visualization. The other side of things I'd like to talk about is obviously the engineering side. Of course, you need to write the code to actually generate these visualizations, but there's also sometimes an important step before you even get to building the visualization, and that is the data preparation step. So when you start out with your data set, you might need to write some code to transform the data first to make it actually usable and suitable for visualization. And what kinds of things would we think about there? We might think about normalizing values, handling empty values, or even creating new columns based on existing ones. So imagine this table here is part of a table with data about car journeys, and we want to visualize something to do with the speed that the car was moving on that journey. We've got these two columns here. We've got the time in minutes the journey took, and we've got the distance traveled in miles. We know that that is enough to be able to calculate the miles per hour. So we can do that. So in a data pre-processing step, you might generate this new column with miles per hour that you can then use in your visualization. So that's one benefit of preparing your data, of doing this pre-processing. Now I would like to show an example of a time when we could have done with some pre-processing, but it was not done. So let's look at this pie chart. So this pie chart is showing the results of a survey carried out in a Nintendo Switch community on what games they've played the most. Now, if you look at the pie chart, you can see, okay, there's a split between quite a few different things here. But then you look at the legend and you see, oh, actually, it's all the same game, but they've just spelt it slightly differently or capitalized it slightly differently. So this chart is really not accurate. Like, you know, all of these things essentially represent the same game, So this should be a completely solid colored 100% Legend of Zelda Breath of the Wild pie chart, but it's not. So, I mean, there are two places that this error could have been addressed, right? You could say that there was an error at the data collection step and that whoever designed the survey should not have allowed people to freely type into the box which game that they played the most. You could say that it would have been more beneficial if they had some kind of drop down or other menu for selecting the game out of a series of options, and this would have avoided the problem. But unfortunately, when you're making data viz, when you're working in this kind of field, you don't always have control over that data collection step. Sometimes you're just given the data set and you've got to do your best with it. And, you know, in this scenario, what I would have done here is I would have normalized this data. So at the very least here, what we could have done is we could sort of run some code over this to make sure that everything is cased the same. And then we probably have some kind of aliasing between, okay, we know that the Legend of Zelda Breath of the Wild with a colon in it is the same as without the colon. We know that BOTW also refers to the same entity. We would have normalized all of that into one single value. And that would have solved all the problems, well, at least some of the problems with this pie chart. So that's the kind of like importance of that engineering kind of step beforehand, the data pre-processing. Now I would like to talk a little bit about why we should visualize data at all. So why go to all the effort? Why can't we just look at data in a table? Why is that not good enough? Can't we just look at the raw values and draw conclusions from that? And the answer is no. So there are a few reasons for this. The first one is that visualizing data is more reliable than purely looking at summary statistics. So to illustrate this, I want to share this, which is, there's this set of data sets called the Datasaurus Dozen, which is put together by Alberto Cairo. Essentially, these are 12 entirely different data sets. They all share the same summary statistics. So you can see these summary statistics up here. These are identical for every single one of these data sets. If you were to look purely at those summary stats, you might be led to believe that the data sets are identical, that the data is the same. But once you plot them on a chart, you know that they're not. You can clearly see there's wildly different things going on in each of these charts. So the moral of the story here is that without plotting them, you'd never get the full story. You absolutely must visualize your data to get a comprehensive overview. And now the next benefit of visualizing data is that it's a lot easier to interpret than raw data. So if we think about ourselves as humans, humans are not inherently good at processing numbers. We don't innately know how to compare big numbers with each other. If we talk about a million versus a billion versus a trillion, we know that they're big numbers, right? But it's very difficult to get a sense of the scale of those numbers. So I would like to share probably one of my favorite visualizations here, which is One Pixel Wealth by Matt Korostoff. And this is wealth shown to scale. And I think this is a really, really amazing data visualization. Again, thinking outside the box, being a bit unorthodox and really hammering a point home. So if we scroll right, we can see 1 pixel on this screen represents $1,000. Here is $68,000, which is the median US household income. Here is $1 million. And then here is $1 billion. And you can see immediately that billion is like massively bigger than a million in a way that might not have clicked in your head without seeing this visualization. And if we continue, this is then compared with $185 billion, which is Jeff Bezos' personal wealth. He's a very rich man, as you can see by the amount that I'm having to scroll right now. And I think this is one of the most shocking visualizations that I've ever seen, to be honest, because I never had any concept of how wealthy billionaires actually were until I saw this. You essentially just keep scrolling and scrolling and scrolling, and you're still deep in Jeff Bezos's money. And eventually you get up to this point where you can see some things compared. So if I keep scrolling, okay. Oh, my finger's so tired from scrolling this chart. We'll get to some comparisons, right? They're coming up now. So here, for example, all the money you'll ever earn in your entire life from the day you're born until the day you die, about $1.7 million. It keeps scrolling. And the next thing we can see is annual cost of healthcare for a family of 4. And you can see how really that is a drop in the ocean compared to how much money Jeff Bezos has. It is absolutely wild. And I think this chart is really great for hammering home that wealth inequality in the USA, because it's only when you see it like this that you realize exactly how big a problem there is. So I won't go on more with this because this chart does go on forever, as you can maybe tell by the scroll bar at the bottom. But again, I will provide this in the resources at the end if you want to explore it at your own leisure. So again, another thing, potential for data storytelling. I think that chart is great for telling a story with data, like, really communicating that and making a point. But let's look at a few examples of where the data storytelling goes wrong and we get the wrong impression from graphs. So go to the next slide. So this section I've titled The Importance of Sensible Data Viz, because I wanted to highlight a few of the really common mistakes. So this is one of the most common mistakes I see. I've seen various versions of this graph. Essentially what we have here is a bar chart showing the average male height in meters for several different countries in the world. And you can see that instead of using bars, they've used a little illustration of a person. And if you look at this for a few minutes, you might notice the problem, which is that for some reason, it looks like men from the Netherlands are 3 times as tall as men from the Philippines. And obviously this is not the case. And this is due to the y-axis not being started at 0. The y-axis here starts at 1.5. And as a result of this, you can see there's a very exaggerated comparative difference between these heights, when in reality, there's not that much difference at all. If we did start this y-axis at 0, we would get a lot more accurate idea of those relative heights. Now, this is quite a sort of silly example, you might say. It's a little bit frivolous. There's no real damage done by this particular chart, but you can see how that could have a much bigger impact if this kind of mistake is made in more serious scenarios. And unfortunately, this kind of mistake is made in more serious scenarios because data viz is like a really hard thing to get right in general. So let's take a look at another example. So here is a bar chart showing the reported age of users versus the number of users. Now, I think part of designing a good visualization is designing for what viewers are going to expect, because humans tend to skim read. So there's a lot of value in sticking to a convention, stick to what people are going to be expecting. Otherwise, people are going to interpret it wrongly. So age is linear. You expect the age to start with the younger ages on the left and end with the older ages on the right. That's kind of the natural expectation for this kind of graph. But you can see that's not the case here. If I just glanced at this without reading the labels, I might think that the number of users, like the highest amount of users, would be in one of the older age categories. But actually, when we have a look at these labels, we can see that they're completely unordered. So the biggest bar is actually the 19 to 25 age group. But unless I'd read that, I might have thought that that was, for example, the 36 to 45 age group, because it would be more natural to see that along that end. So again, here's an example of where we need the the axes to be ordered in a way that makes sense so that we can interpret the data in the correct way. Now, this example and the previous example might be kind of innocent mistakes, and that's fair enough. But let's look at an example which probably isn't an innocent mistake, unfortunately. So let's take a look at this chart. So when charts are designed for the media, as well as being designed to be impactful and to grab the attention of the audience, they're usually designed to support a certain viewpoint. And here is a chart which I believe is purposefully misleading. So here we have gun deaths in Florida plotted over time, and we have particular attention drawn to this point in 2005 when Florida enacted its Stand Your Ground law. So the stand your ground law essentially meant that it's legal to use deadly force if you feel like you're in a situation that calls for it. Now, at a first glance at this chart, you might think that after the stand your ground law was enacted, gun deaths dropped massively. But actually, that's not the case, because they've done something very sneaky with this graph. So our brains are conditioned to think that 0 starts at the bottom of the y-axis here, and the highest values are at the top. But actually, what they've done is they've flipped that. So 0 is starting at the top, and they put the highest value at the bottom. So with that in consideration, we can see that the gun deaths didn't drop after this point. They actually rose very, very steeply. So here is an example where I think it's been kind of purposefully designed to mislead the viewer who's more used to that more conventional way of plotting the y-axis. And I think obviously the intent of this graph was that they want people to believe that the stand your ground law was a good thing, when in fact it seems like it had a very negative impact. So where is data viz used? Data viz is all around us. So I've talked a little bit about data viz in the media and things like that. I hope you're kind of a little bit interested in data viz by now, and I hope you'll promise me you'll use the powers of data viz for good and not evil, as we saw in the last couple of slides. But yeah, let's talk about what opportunities are out there. What kind of fields can you go into with data viz? So we have here. So for example, we have, as mentioned, journalism and the media. We've got things like newspapers, news websites, all those kinds of things, or even like television as well, especially like if you've got sort of like election night and that kind of thing, often got a few charts going on in the background. We've got maps, again, I mentioned those, and I think a really good example of maps is weather reports. If you watch the weather on TV, essentially that's data viz. You can have literal heat maps there, showing like the hot areas of the country versus the cold areas of the country. You see the weather coming in, like the rain coming in from different places. That is all data viz. And then we've got fields like business intelligence and science, where data analysis and visualization is key to identifying trends and anomalies, making predictions and helping build strategy. And there's a little bit of a machine learning element there as well, because like once you've processed your data, you can sort of train machine learning models and stuff like that, and then build charts off of those predictions. But machine learning is a very big field in its own, so I'm not going to get into that too much here. And something that I want to highlight as well. So at the heart of data viz, it's all about communication and like how do you best communicate that data. Data viz might seem quite niche, but it applies across a really broad range of fields. And it's super fun to do, and it builds your skills in multiple areas. So you've got skills being built in data processing, statistical analysis, DOM manipulation if you're building stuff for the web, design, communication, all the good stuff. Like it touches on quite a few different areas. And personally, if I was looking at a CV, I would be really excited to see data viz on a CV, just because it shows that you're engaging in a lot of complex areas, and it's a little bit more exciting than your standard like random quote generator or something like that. It's like a really cool thing to see people that are interested in. And also it's a very freelanceable skill. A lot of data viz professionals work as consultants. So if that is a route that you would like to go down, data viz might be for you. Right, so starting your adventure, skills to focus on and next steps. How might we learn more about data viz? So the first step here, I would say, is that to focus on data viz fundamentals, and these would be concepts that are transferable between different programming languages. So there is a great book called Fundamentals of Data Visualization by Klaus Wilke, and it's available for free online. Again, I will share this link as part of the resources. But this will like walk you through like loads of different areas, and this isn't programming language specific. So again, transferable skills. You learn about your coordinate systems and axes, scales, best ways to visualize, which chart types are good for which sorts of data, and so on and so forth. And it also has a really good section on telling a story, which goes into the data storytelling stuff that I mentioned previously. So yeah, focusing on data viz fundamentals is great, just like learning about all those different conventions. And then the next important bit is probably to choose a programming language to focus on. So I would say focus on one at first, or if you're familiar with any of these languages already, great, pick it, dive it in, start building data viz with it. But just to go through a kind of overview of these like 3 main languages that I would consider for data viz. We've got the R language, which is a language that's actually designed for statistical analysis. And within that, there's a set of packages called the tidyverse, which handle chart generation and data manipulation, transformation, and that kind of thing. The R community is also really nice, and they have a hashtag called Tidy Tuesday. And every Tuesday they release a new data set for somebody, for everyone in the community to kind of try and visualize something with, right? So it's a great way to get involved and to share your work with the community. If you build data viz using that week's data set, share it with the hashtag. Get chatting with people is a nice way to learn, a nice way to brush up on your skills, and a nice way to network as well. So would recommend that. We've got Python, which is a great multi-purpose language. Python is also probably like the most common language for machine learning stuff. So if you're interested in that sort of thing, Python might be the way to go. You'll be working with pandas, which is the library for, again, like data transformation, manipulation, and matplotlib and seaborn are like the most common libraries for charting. And last but not least, JavaScript. If you're building for the web, JavaScript is definitely the way to go. If you want to build interactive charts, I would probably like lean into JavaScript. Again, JavaScript is quite a multi-purpose language. You probably already know you've got your front end JS stuff, and you've also got Node for server side things. So all of those kind of data pre-processing stuff, if you need to read CSVs and that kind of thing, you can do that with Node. But probably the most important library for data viz in the JS ecosystem is D3. It's very hard to find any charting library for JavaScript that isn't built on top of D3. It's that ubiquitous. It's a great library, and it sort of makes a lot of very low level things quite accessible. You might say that there is a little bit of a learning curve with it, but it's definitely fun to dig into. And there are a number of courses and such on D3 that I would recommend. Again, I will pass through some links in the resources section. So yeah, I guess the number one thing that I would recommend here is just start building things. If you're interested in data viz, just like dig in there and like choose something you're interested in. There are several places where you can find data sets. So you've got places like the Office for National Statistics. You've got Kaggle, which is a website where you can find data sets, and they also have courses on data viz, on machine learning, and that sort of thing. It's a really useful site, and they run competitions too, which is pretty cool. You've got places like the datasets subreddit. There's a lot of places, again, I'll share these links, but there's a lot of places where you can go digging around to find data sets. You can also collate your own data sets if you've got an interest that you especially want to visualize. Don't ever be scared to kind of dig around on Wikipedia, knock up a spreadsheet of your own, and then try and visualize it, because I promise it is fun. And you can come to some really interesting insights when you're exploring data for yourself that you wouldn't necessarily come to if you were just kind of taking in that information from elsewhere. And last but not least, it's really satisfying, again, to like share your data viz stuff and like see how other people interact with it and see what how other people interpret it. Because like, I think the number one skill here to own, again, is that kind of element of communication, of being able to convey the things that you want to convey in a way that's accessible to everyone. So yeah, building things, go for it. It's the way to go. Like, it's, in my opinion, best way to learn. Just dig in, start building some stuff. It's fun, I promise. Okay, so thanks everyone for listening. I think I must have talked really, really fast because I seem to have got through my content faster than anticipated. So I'm sorry if I was talking at a pace that was a little bit too speedy. But I'm really happy to take any questions now or have a chat. either now, or you can always like reach out to me. My email address is down here, or reach out to Amy, who is amy@graphy.com, or connect with us on LinkedIn as well if you have any questions or want to follow up. Thanks, everyone.
Thank you. Thank you very much for that, Liz. I think that the most, not the most interesting bit for me, but that I found it really fascinating, the bit about the gun deaths and the reversal of that axis. Like, that's insane. I didn't know people would do that and actually release that as a graph.
I know, it's like once you realize the kind of things that people do, like once you start looking out for it in newspapers and in news articles and things like that, it's actually really scary how much the media kind of relies on slightly fiddling the charts to get a bigger reaction or to try and support certain points of view. Like another common thing that I see is scales being kind of purposefully like squished or extended to make a curve seem more dramatic than it actually is, because they know that people are going to buy the paper or read the news if they are like, whoa, that's something's going on there. But in reality, if they had plotted it in a much more sensible way, it wouldn't look so dramatic.
Interesting. Oh, I feel like you've ruined my afternoon. I'm going to be looking at loads of data and visualizing it somehow. So that's awesome. Thank you so much. That was really insightful. We've had some questions come in. One of them is, how would you go about coding your data viz? Are there any specific frameworks needed? I know you've just got into D3 and some of the others as well, but is there anything else that you could share on that?
Yeah, so I've mentioned kind of like briefly at the end, like you've got a choice of programming languages there. Me personally, because I'm focused on building for the web, I would be using D3. There's this really great website called Observable, which again is something that I will share in the resources. But Observable is like a really cool place to kind of play. It's like start playing with D3 and these kinds of visualizations. So if I click on Explore here, you can see if I click on any of these things, hopefully. Okay. Yeah, so you can see you can sort of like play with the code live here on Observable. It's like a really cool website. So I can actually like edit this or like edit the code for these kinds of charts and like see the things like the charts update in real time, which is really cool. So this is a good website if you want to get started and just have like a little bit of a playground for building data viz. There are some good kind of tutorials and stuff on here as well. So yeah, like definitely like D3. One thing you might find with D3 is if you want to use it with a framework like React, D3 might at outset not seem like a natural fit, just because a lot of like vanilla D3, like classically it kind of like mutates the DOM, so it kind of interferes a little bit with the React lifecycle, but you can make them work together in a compatible way. Essentially, the way we build it at Graphy is we use D3's helper functions to generate stuff like our scales, and then we can just apply them directly to our SVG elements and things like that.
Fantastic, thank you. So in reality, someone could just plug some data in essentially to Observable and then have a play and see how that all works. Is that how that works?
Yeah, so essentially you'd they've got a bunch of different templates here. So like there's different kind of playgrounds that people have put together, but essentially it's a platform where you can write the code for your data, and you can write the code for your data visualization. You can write like insert your data there, sort of thing, and then anyone can come in and sort of like play with it, like tweak it and kind of see what happens to the chart. So it's quite fun.
Thank you. Another question, are there any certifications that are common to have in the industry?
So that is a really good question, especially because I actually myself, I don't have any like data viz specific certifications. So I guess that's a kind of good sign that you can get into this sort of thing without needing a certification. I would say if you want to go heavily into the data science side of things, so if you're like working in like data analysis and that kind of thing, you'd probably be useful to have a degree in statistics or something like that, because I think those areas, especially like machine learning and like data analysis, probably need a bit more of a like mathematical or a statistical background. But definitely, I guess I'm probably a an example of how it's possible to get into some kind of data viz field without any specific qualification other than just like a passion for data viz and you know, the drive to build things that are accurate and useful to people.
Fantastic. Thank you. What advice would you give to someone just getting started? Would you suggest starting a side or passion project or applying for internships?
Okay, yeah, so I absolutely would, again, as mentioned, just get started building things. I think data viz is like a really great thing to see on a portfolio for the reasons that I mentioned, which is it kind of like cuts across a lot of areas of programming, like in my opinion, because obviously you've got data crunching stuff, you've got the front-endy visualization kind of stuff. It's just a really, really cool thing to have. And I think it's like a little bit unusual to have on a CV as well. So yeah, I definitely would advocate for side projects. Just pick something you're interested in. Maybe you could roll with like the community challenge type stuff, like I mentioned, the Tidy Tuesday community on Twitter. Sort of like get involved with those kinds of things. And again, like don't be afraid to ask people for permission to use their data to make visualizations, because people are, in my experience, are very open to that, right? If you say, hey, can I take your stuff and make a chart? They'll probably be blown away by it, even by the simplest thing. So yeah, like definitely get started, put yourself out there, share your visualizations with people, see what kind of impact they have, and you know, how people interpret them, and use that as feedback to improve. You know, always be asking yourself, okay, I've built this visualization. Did I achieve my goal here? Did people get the point of this visualization, or were they confused? That kind of thing. Just keep rolling with the feedback and keep building more and more awesome things.
So with that in mind, sorry, would you suggest then essentially building a visualization and then share that online and see what people think, that sort of thing?
Yeah, definitely. Yeah, yeah. I think building stuff as a side project and then sharing it is a great idea. One idea I've had in my head that I've wanted to do for a long time, I've not got around to, is I've always wanted to actually write a blog and make little like charts of various things that I find interesting and share that as blog posts, like stuff like that. I think it's cool. And like I say, there are also communities like there's the Data is Beautiful subreddit on Reddit where people share their charts. So that's also another really nice place to get recognition and to get feedback and to sort of build a name for yourself in the data viz community.
Oh, fantastic. Thank you. How do you determine which type of visualization would be suitable for a data set? How do you determine that?
Okay, so I think I would probably defer here to like this book that I mentioned on the fundamentals of data viz. I don't know if I'm still screen sharing, but hopefully I am, because this has an entire section on it. And like there's a lot of things that would impact which viz type that you might choose, because there are a lot of different types of charts. I'm aware in my presentation I just kind of focused on a bar chart and a line chart, and that was essentially because it would take so much time to go through every single possible iteration of a chart. But essentially there are a set of rules, like for example, between like bars and lines, you would always use a line chart for your time series data. For a bar chart, you would always have sort of categorical data and that kind of thing. Yeah, but I will share this link because there is lots of wisdom to be gained from this.
Thank you. And how do you, oh yeah, I've just asked that one. We've got, hi Liz, great presentation. Is there any reason why you wouldn't choose to use data visualization tools such as Tableau, I can't say that, or Power BI, which have many inbuilt features, particularly for data preparation?
That's a really cool question. Awesome. So I think in general, I know that businesses kind of tend to like lean a lot on these sorts of tools, but sometimes businesses might need something that's more custom, especially as well if you're designing. Okay, so I'll focus on the businesses side of things first, actually. So businesses might need something more custom that they find that they can't achieve with those tools, or those tools are kind of difficult to use, right? I know a lot of people find them quite clunky. So they might, like a business might find it either like more cost effective or just like better to hire an independent contractor to like hand make the visualizations for them. And then you've got the other side of things, which is designing for print. So that goes back to things like, things like this, this kind of visualize, okay, this is for the web, but you might have some charts which are designed to be more aesthetic. And in that scenario, tools like Tableau, or if you're making a chart in Google Sheets, for example, it's not very beautiful. Imagine you want a beautiful data visualization as like your center page spread of a magazine. You probably want something really custom designed for that. To ensure that it's pretty, essentially. And you can do, again, a lot more of these kind of custom types of visualization. Like you wouldn't be able to achieve something like this in Tableau or in Google Sheets or Excel.
Okay, so it's essentially to do with maybe how bespoke it is and the sort of thing you're actually trying to work on, and where you're going to be using the data or the visualization afterwards.
Yeah, essentially, like there's if you're using a tool, then you're confined to the, what that tool can support, essentially. And I think tools that are going to be primarily designed to just cover the common use cases, right? They're not trying to be aesthetic, they're not trying to be beautiful, they just want to get your data visualized in a way that will help your business. But sometimes you do want something more custom, you want something more attractive, you want something that will really pull people in. And in that case, I think you need to go with something bespoke.
Fantastic, thank you. Do we have any more questions from anybody else? Any more questions? So I'll pause for a little bit. You are able to mute yourself now, by the way, if you would like to if you would like to ask anything. Otherwise, thank you very much, Liz. Thank you very much to Liz and the team at Graphy as well for taking the time for this session today. It's been really informative, and we have had loads of questions as well, which shows that people found it really interesting, and I know that I definitely want to go away and do a bunch of research into it as well. So thank you very much for that. I'm going to be sending out a feedback form after this, so we'd love to capture some of the feedback from people who have attended today. What we may do is somebody who fills out the feedback form may get the fundamentals of data visualization book as well. So we're happy to provide that to somebody who has attended today, chosen at random, obviously, but we'll be sending out the feedback form. And then we'll also be sending out the details from Liz as well, to anybody who would like to have some resources, some more information about the session. But thank you very much.
Thanks so much, everyone.
Thank you for having us along.
Thank you.
Bye.
See you all soon. Bye.